So here's another idea to basically synchronize buying milk between two partners. We agree on a protocol, and this protocol is basically that each one of us will have his own node. So I will have red slips and you will have yellow slips. Okay? So now there are red slips and there are yellow slips. When I'm writing a note, when I'm going into the kitchen, the first thing I do is that I raise a flag that I'm going to the kitchen. So note A is equal to 1. I then check if you have left me any notes. Okay, these notes might be basically that, you know what, I'm going to go and buy milk. So if node B is equal to 0, if you have not basically told me that you're going to buy milk, then I open the fridge, I check for milk, I do not find milk, I go buy milk and I add one milk, and then when I'm done with this process, I remove my note. Okay. You, on the other hand, you'll start by basically always having a node B, which is basically your version of the node. Whenever you're going to check anything, you basically write a note that, by the way, I'm going to check anything. I'm going to check for milk, sorry. You go inside, you have written your note, so now I know that you're in there if I come in, and you check if there's any note from myself. So there's no note from me, note A is equal to 0, and then you check for the milk. So right now you have previously you have been checking for the milk first and then writing the notes second. Now you're basically doing the exact opposite. You check for the notes. If there are no notes, you buy the milk. You go and buy the milk and you write your note even for anything. So let me ask you, does this solution work? And the answer is no, because you can cause a deadlock. So let us suppose that I come in, I write note A, I get distracted. You come in, you write note B, you get you write note B, and basically you look for if I've written any notes, okay, and you find that note A is equal to 1 because I was distracted. I did not go past that. But you have already not written your note B. And since I am dumb, since the two threads are dumb, let's not get personal. So since as the two threads are dumb, basically, so the first one, note A, sets note A to 1, gets distracted, gets evicted from the processor. Second thread gets the processor, sets note B to 1, and then checks for note A, finds that note A is equal to 1. So now it needs to wait, right? Because this is what we said will be what we need to do with a lock. You basically need to wait. Okay. On the other hand, I come back, I get scheduled again, and I look for node B, and I find that node B is equal to 1. So now both of us are deadlocked. I mean, we will either both of us will just stay hung forever, both threads will be hung forever, or none of them will buy the milk. So you will either get the case where, well, we didn't do what we are supposed to do, or we just got stuck forever. So this is what is called a deadlock. Third try. So we write a note A, we write a note B, okay, and again you basically one of them will wait for note B, spin on note B, basically wait until note B is equal to 0 again. Okay, so it checks if note B has been changed. And the second one, on the other hand, does not spin forever. It just checks if note A is equal to 0, and then if yes, it checks for milk, and then goes and buys milk, and then changes note B. So when these two are running in parallel, let us go back to programming basically. So suppose that first line on path A gets executed. Node A is equal to 1. And then it gets evicted, gets preempted. Okay? And node B gets, and path B gets scheduled. So node B is set to 1. Okay? And then what would happen is that, suppose that now path A gets rescheduled again. So you go back to the left hand side and you basically find while node B is equal to 1. So now we are going to wait forever until B releases its lock. You just wait, you just spin, wait. So while you're spinning, you release the processor. So again, path B gets scheduled, and now it asks the question, if node A is equal to 0, is it? No, it's not, because I just set it to 1. So it will skip the if statements and it will just set node B to 0. So now, since node B is 0, once path A gets rescheduled, is node B equal to 1? No, it's not. So now it will check for milk, it will add milk, and it will change node A. The difference between this and the previous answer is that now you have one of them waiting forever, on basically spinning forever until the lock is released, while the other one does not spin. The other one just tries, and if it finds that that some other lock has been acquired, not A basically has been acquired, it just quits. Okay, so in this case B will quit and A will perform the addition of milk.